1, 2, Web3.
1, 2, Web3. 1, 2, Web3.
1, 2, Web3.
1, 2, Web3.
1, 2, Web3.
1, 2, Web3.
1, 2, Web3.
Greetings, developers, hackathon participants, and metaverse architects. Welcome back to another hackathon live stream for 1.2 Web3. I'm here today with Patrick of Chainlink, and if you were here for our opening ceremony, you'll remember that Patrick had a really exciting intro video for us, so we're looking forward to this workshop for sure. Patrick, welcome to the stage.
Hello. Thank you so much for having me. Hello, hackers, engineers. Hopefully everyone's doing well. Can I see the comments here? Yeah, I can see the comments rolling through. Hello.
Yeah, and if anything comes in on the comments while you're, got a different screen up or something, we can always pull up questions at the end, or if you want to take them in the middle, either way is fine with me.
All right, awesome. Yeah, we can give it a couple minutes for people to come on in and see some comments. Because yeah, this is a live session. So one of the biggest advantages of live sessions is being able to interact with you all live, which is great. Because otherwise you could just go watch one of the many videos that we have out there. So welcome everybody to the stream. Hopefully everyone is doing fantastically. How is everybody doing today? Let's see in the chat.
Day to day with the merge and everything, and here we are just talking about building.
Yeah, definitely happy merge day. 100,000% happy merge day. So hopefully everyone is excited for the merge. Yeah, how are you doing? How are you doing, Phil?
Oh, awesome. I'm doing great, always, definitely. And yeah, just very much excited to see how some of these projects play out. If you've been joining us in gather.town, then maybe you've had a chance to talk with me or some of the other members of our team about your project. If you haven't yet, it's not too late. We're going to be meeting there after this live stream and just having a great time. It's a real friendly, casual discussion there. So don't feel like you can't just sit in the corner and lurk a little bit. That's okay too.
Absolutely. So
all right.
I'm seeing some people in the chat here. Welcome, waiting for the merge. All right, great. Let me go ahead and start my little presentation here and we'll just jump right into it. Awesome. All right, I'm gonna go ahead and switch over to the presentation here. Bada bing, bada boom. Cool. All right, so let's go ahead and jump into this. So today we're gonna be talking about Chainlink. We're going to be talking about hybrid smart contracts and decentralized Oracle networks. So, and we're going to be talking about a couple of things here. So we're first going to talk about why we're here. What are we doing? What are we building? And then we're going to talk about some Chainlink superpowers as well. So this is going to be a presentation that's going to go over the introduction of what makes Chainlink so incredible. But in order to really understand that, we first need to understand what we're doing here. What are we building? What are we building when we're building in Web3? And with that, I'm going to give you all a gift, a wonderful little gift that's going to show you, that's going to tell you a way to teach your friends when they ask, hey, like, what are you doing in Web3? I'm going to give you the answer here. The easiest way to explain what we're building in Web3. And for those of you who do not know, my name is Patrick Collins. I'm a developer advocate on the Chainlink project. You can find my social information there. So in order to understand Chainlink, we first need to really understand the purpose of smart contracts. What is a smart contract and why are they so important? Why are we here? What are we building? And the answer to this is trust minimized agreements. All right. So remember this. This is why we are here. We're building trust minimized agreements. Now, if you tell your friends and your family, hey, I'm building trust minimized agreements, they're probably going to be like, what the heck does that mean? What are you talking about? You're crazy. You're insane. So an easier way to lay it up is just say, hey, I build technology that enables unbreakable promises. That's what smart contracts do. They enable us to build unbreakable promises. Or if you're, a JavaScript developer, unbreakable promises, not to be confused with those. Get it? Because JavaScript is promise-based, programming jokes. It's great. Okay. In all of our agreements today, we have issues with trust and promises. Everything that we do, right? If you get a service like an oil change, right? You are trusting that they're actually going to change your oil with new oil, right? If you go to the bank and you put money in, you're trusting that when you come back in a week to withdraw cash, they will have the cash for you. There's a trust element there. If you play the lottery, you're doing what? You're hoping, your fingers are crossed, that they're going to give you a fair chance at winning the lottery. There's this massive trust assumption there. Now, a good example that I like to give about when these trusts assumptions that we make fall through the cracks, and this is the example I give to people who aren't in this space, because this one's really easy to understand, is the McDonald's McMillions scandal. So what happened was back in the day, I think in like the 1980s, McDonald's ran this promotion called the Monopoly promotion. And the way that it worked was if you bought their McNuggets, they're going to give you a fair chance at winning $1 million, right? So whenever you bought their food, you were buying into this promise that, hey, we promise we're going to give you a fair chance at winning $1 million. You were buying into this agreement with them. However, when you bought their food, you actually had a rock solid 0% chance to win. And they broke their promise, right? They made this promise, hey, we promise we'll give you a fair chance to win, when in fact your chance to win was 0. So you might say, okay, Patrick, that's kind of a weird example to give, McDonald's McMillions scandal, which was like $13 to $24 million down the tube. What about another example? Well, another example that might be a little bit more impactful is when a run of the banks happen. When a bank goes, hey, we'll keep your money safe, we promise, and then they don't. And then you go to withdraw your money and they go, oh, sorry, we spent it all. We don't have it anymore. And this has actually happened many times, right? Here's a picture from the Great Depression. Run of the banks. Banks literally didn't have money to give you. So you were just shit out of luck if you went to go grab money. And you might be saying, hey, Patrick, that's cool, but how about a more modern example? And I'll go, great. What happened last year or 2 years ago with Robinhood, where Robinhood painted this picture, said, hey, come use our platform. We promise we'll let you invest. We promise we'll give you access to the stock market. And then when push came to shove, they said, oh, well, not like that. And they revoked your promises. So the issue here is that in these traditional agreements, there's this conflict of interest. There's this trust assumption that's made. However, the person who's making these agreements, making these contracts, often has a conflict of interest. And they also have a switch that they can flip, a centralized flip that they control to just go back on their promise, to break their promise when whatever a promise that they made no longer benefits them. And this has caused millions and millions of dollars in damage, billions and trillions of dollars in damage, just in the last year. With Web3, we have this ability to have these cryptographic agreements. We have a smart contract that cannot break its promise because it's cryptographic, it's mathematical. Whatever input you put in will automatically trigger the output that will always be exactly the same, right? So we're moving away from these paper guarantees, this brand-based guarantees where you have to trust this brand, trust my logo, and we move to this cryptographic guarantee where instead we trust that the math works, right? Which would you rather trust? Math saying 2 + 2 = 4, or somebody going behind closed door and saying, hey, I promise the answer here was 4, right? You're going to trust the math-based agreement always. And not only that, but smart contracts have these other amazing properties that we're not going to go into. I usually like to boil it down just to this one because it makes it a lot easier to digest, but they're also fantastic in security, guaranteed execution, transparency, trust minimization, efficiency. The story goes on and on. So we reach this conclusion where we have truth is better than trust. Given a guaranteed agreement or one where you have to trust a counterparty to do the right thing, which are you going to pick? For me, the answer is overwhelmingly, I'm always going to pick the one where I can mathematically verify the outcome is always going to be the same. And to me, that is beyond potent, and that's why we're here right now. So, okay, cool. So now we're up to speed on that. And then if anybody has any questions on that, like I said, this is a live presentation. Feel free to ask some questions in the chat. If there's any questions on that, if that doesn't make sense to anybody, feel free to drop your questions in the chat now. And I'll even give a minute for questions here. Any questions on this? I'll even flip back to be like, I'm seriously waiting. What questions do you have? I'm looking at the chat. Maybe there are no questions, which is fine too. Maybe that was a refresher for a lot of you, which is fine, which is great.
And don't worry, we're gonna stop again. So if you're shy, you'll have another chance.
Yes. Maybe there are just a lot of shy people here, which is okay. Shy, welcome shy people. That is okay. Oh, no question from my side. Okay, great. A lot of you might be senior engineers and already know all of this, so that works perfectly as well. So let's jump back. So, okay, cool. So we've solved. Oh, I'm back. Oh, here we are. Okay, so cool. So we solved this problem of smart contracts, right? Great. However, they still have a number of problems. They still have some issues. One of the biggest problems with traditional smart contracts is something called the Oracle problem. These smart contracts are awesome. They're these cryptographic agreements, but they are unable to connect to the real world. They can't do APIs. They can't connect to any off-chain resources on their own. And this is because of the way that they're built. This is intentional. These are deterministic systems. They won't be able to reach a consensus if they have to call APIs or get random numbers. None of the nodes would be able to agree on what the state of the blockchain is. So this is a good thing. It's a good thing because it allows the consensus to be easier, but it's a bad thing because we can't interact with the real world in any meaningful way. Now, this is where something called an oracle comes into play. A blockchain oracle is going to be any device that interacts with the off-chain world to provide external data or computation to smart contracts. And you might think, okay, cool, great. So we solved the problem again. We have oracles. Well, it doesn't actually end there. Centralized oracles are a massive point of failure. So if you have a single node or a single data source or a single anything, you've just done all this work to make your smart contract decentralized and do all this computation, but you've just reintroduced the problem that the whole space was trying to solve, right? What are we trying to solve? What's the fundamental piece that Web3 does? Again, it's these trust minimized agreements. Once we reintroduce a centralized source, we're doing what? We're reintroducing that trust assumption, which to me is essentially negating the purpose of building on the blockchain, right? You might as well build your application in Python or something. So the solution to this is building a decentralized Oracle network. And this is where Chainlink comes into play. Chainlink is a decentralized Oracle network that can bring data, origin proofs, external computation, and all the wonderful goodies of the real world into our cryptographic agreements. And this gives rise to something called hybrid smart contracts, where they're a combination of on-chain and off-chain systems, right? Where you can get external data, enterprise systems, traditional payments, Chainlink services, all this stuff to make our smart contracts actually have a meaningful impact on our everyday lives. So let's talk about some of the cool things that Chainlink can enable for us. These out-of-the-box solutions. What are some of the easiest things we can spin up right now and build incredibly powerful systems with? Well, the first one is Chainlink data feeds, which is powering over 65 billion in the DeFi world. That number might be a little bit outdated, but it's something around that number, maybe 30 billion, 70 billion, something around there, depending on the day, right? And these decentralized data feeds or these decentralized price feeds, they take data from the real world, like information about gold, the price of gold, information about the price of Ethereum, the price of Bitcoin, all these kind of meta things that we assign to real world objects, grab it from these data providers and send it through a network of Chainlink nodes and deliver it to a contract on chain that your agreements, your smart contracts can read from. And if you head over to data.chain.link, you can see some examples of these price feeds, of these data feeds. You can see all the different oracles that are providing the data. You can see the trusted answer. You can see information about the contracts and all this wonderful things. These data feeds are being used by some of the largest protocols in the space, the largest DeFi protocols in the space. For example, Synthetics, which creates synthetic assets. It needs the pricing information in order to mint these synthetic assets using the synth as collateral. SushiSwap, which is using the Chainlink price feeds to do loans to leverage buy on your DEX. Compound for lending and borrowing, for borrowing extra data, for getting the pricing information so that it can price your collateral so it knows how much to lend out. Aave, same thing. Getting the information so when you put your collateral down, it knows how much that collateral is worth. And these are some of the biggest and most powerful projects in the space. And if you head over to docs.chain.link, you can scroll down to get the latest price in the EVM chain. You can also do Solana as well. And there's a button at the bottom saying deploy this contract to Remix. Click it, deploy it to Remix. Boom, automatically see it in action. It is incredibly powerful. So that is the price feeds. Any questions on that? And I'm going to give another minute for questions here. Don't worry, we got a lot of stuff to cover, but I do want to make sure that any questions about that do get answered. So any thoughts, comments, questions? Or are you all Chainlink pros? You're all like crystal clear on this? Any questions on any of this so far?
So I'll just give a comment while we're waiting
Love
here.
Yeah.
You're seeing the list that you had. I mean, Chainlink really is like the Oracle infrastructure for all of the major DeFi dApps that we're seeing right now. And so if you're thinking of building DeFi, that might be a hint to you what the other major players are using. And also you're going to be able to learn from their experience, because each of these dApps functions differently and has implemented Chainlink in just slightly different ways. And so those types of things you can really go to school on when you're trying to figure out, how do I provide accurate, up-to-date information for my dApp? Because it's hugely important, especially if you're looking to monetize your DeFi.
Absolutely. Spot on. And one of my favorite things to do actually is deconstruct some of these large DeFi applications into minimalist examples. And if you want, we can go into that as well. I've got a repo called DeFi Minimal, where we take some of these protocols, we minimize it. And a lot of them, like Aave, like Compound, like Maker, can be minimized much, much easier when you do just do like import Chainlink, get the price feed, boom, go. Right? Pricing information is some of the most important information you can get in DeFi. So absolutely, Phil, spot on. Yes. Okay, we have a question here. Can I change my smart contracts once deployed? Great question. That's less about what we've talked about, but that's okay. So the answer is kind of. That's a much longer conversation. So I'll give you the skinny. I have a video on it called Upgradable Smart Contracts, or the 4 different ways that you can change your contracts once they've been deployed. And all of this is transparent, though. Some of the biggest ways to change it is either you don't change it, right? You deploy it, and that's exactly how it's going to be forever, which a lot of people really like, because that's kind of the most censorship resistant way to have a smart contract. Some people add parameters where, some controlling body can control the parameters. Now, once you do that, obviously you're once again adding this trusting element in there. So you have to take that into account. And then some of the most popular proxy mechanics allow what's called upgradable smart contracts. We can talk about that later. But yes, you can upgrade your smart contracts using some really cool design patterns. Great question. I have a question. I'm using random VRF and geolocation in our game. Just wondering if it makes sense kind of run a Chainlink node inside the game itself to provide nodes while the player is playing. That might be a longer answer too. The answer is kind of. So if you're doing geolocation, that's definitely something that a Chainlink node would be great at. If you're just running one node, what are you doing though? You're reintroducing that trust assumption again. As an MVP though, that's great. And for these hackathons, running one node, having one data source, that's great, right? Because it's MVP. Once you go to production, you do want to add more nodes, add more data providers. And when you say running the node inside the game itself, that can be a little tricky. I guess I'm not sure what you mean by running inside the game. Maybe that's a conversation for later. But yeah, for an MVP, I probably would recommend actually running a node. That sounds awesome.
For this one, we can discuss it more in gather.town. after the workshop here.
There you go. Yes. Awesome. And last question here. What about the data you want is not currently on chain, or am I looking at this wrong? No, great question. We'll get to that. Great question. All right, let's go back. We will definitely get to that. So that is the price feeds. Okay, cool. Next out of the box feature is going to be Chainlink VRF, securing randomness for your applications. So as we know, as I just said earlier, blockchains are deterministic, right? And if you have a deterministic blockchain, that means you cannot have randomness, because if you're deterministic, that means it's not random, right? And this is an issue because we do need randomness for a lot of things that we do, right? We want random NFTs. We want random sampling of data. There's all these reasons to have randomness. So what Chainlink VRF does is it looks off chain to get us a random number and then cryptographically verifies that the number is actually random. So we have provably random numbers, enabling us to have incredibly powerful applications using randomness. Now, some of the some protocols using this, one of my absolute favorite ones is one called Pool Together, where they do raffles as an investing vehicle. And the coolest thing is, unlike traditional like lotteries, where your expected outcome when you buy a lottery ticket is negative, right? There's a very high chance you are not going to win money. The expected outcome of Pool Together is actually positive, which is insane, right? If everyone pools their money together, the economy of scale allows them to gain much more yield in DeFi, and you can win a lot of money, which is awesome, right? So they use this random number to pick random winners weekly. And then there's a ton of other examples of using Chainlink VRF. You have Axe Infinity for their gaming application. You have Pokemon's for NFTs. You have Avagochi for randomizing your NFTs. There's a ton of really cool stuff you can do with cryptographically proven random numbers. Next out of the box feature is going to be Chainlink Keepers, which is decentralized event-driven execution. Now, what does that mean? Let's say you have a contract and you want it to every week update, right? Or every week you want some liquidity to move, or every day you want to do something, or you want to schedule something based off of some event. What you can do then is you can deploy your smart contract that connects to these Chainlink Keepers, and you tell the Chainlink Keepers, hey, every X event happens, I want you to do something. And you can schedule that in a decentralized manner. So what happens is these Chainlink nodes check the registry, and they check your contracts to see if it's time to trigger an update. If it's time to trigger an update, your contract responds to them and says, hey, it's time to trigger an update. Chainlink nodes go, great, and they will update it for you. And the coolest thing about this is they do these updates in a decentralized manner. These are called upkeeps. And it is incredibly powerful. We can talk more about that as well. And once again, the documentation for this is fantastic. You can check it out. All these have Remix links that you can just click, see a sample contract in Remix, which is great. And finally, end-to-end reliability really is the promise of these smart contracts. Chainlink additionally has this final out-of-the-box feature called any API, or Chainlink API calls, which allows you to take any API call or any off-chain data source, really, connect it through a Chainlink node and bring that data on chain. So this will answer the question, hey, like, what if we don't have data on chain? Well, great, Chainlink node has that feature as well. The issue with this, though, is this takes a little bit more finesse to get correct, right? If you're using a single API or a single data source, are you reintroducing that trust minimization problem? Are you reintroducing that trust assumption? Yes, you are. If that data is flowing through a single Chainlink node, is that reintroducing the trust assumption? Yes, it is. So these can take a little bit more finesse, right? You want to get a decentralized group of data providers, a decentralized group of Chainlink nodes to provide the data to your smart contracts. Now, for these hackathons, I highly recommend, for just building it, just have it be centralized. And that's okay, right? It's an MVP, it's a hackathon. You can worry about scaling it out later on. But for going production, you do want to make sure you take these centralized risks into account, and you do your best, obviously, to mitigate them, or work with some established decentralized networks to bring your data on chain, so that you continue to have these trust minimized agreements, which once again here is in big and bold. This is what we're doing here. We're building trust minimized agreements. Now, if you want, we can go to docs.chain.link. This is going to be the home, right at the top. We have some links getting started. If you want to just get started, really understand what's going on, we can also go to EVM chains. If you already kind of know what you're doing, you can go down to data feeds, right? Using data feeds, we have some Solidity here, Open and Remix. We have Viper support, some JavaScript, Web3.js, Ethers.js, Python. We can scroll down using randomness, get a random number. Once again, we scroll down, we can see all the Solidity code here. We can open and remix. Once again, Viper support in a separate repo. We have support for the getting any API, and then of course, automate contracts, which is your Chainlink Keeper. So this is going to be your home base if you're working on Solana. You have Solana documentation as well to go ahead and get started. And it is a phenomenal resource. Highly recommend everyone check out docs.chain.link. It is wonderful. And if you're looking for inspiration, if you're looking for ways to get started, definitely be sure to check out 77 smart contract use cases enabled by Chainlink. If you just Google that, the article will show up. It is phenomenal, and it just goes through all these things that have yet to be built. People always make the joke like we're early. We are early. There's so much left to be built in this space. Now, if you're looking for where can I learn, once again, docs.chain.link is phenomenal. Blog.chain.link is really good. Chainlink YouTube has some phenomenal courses. Free Code Camp, once again, is amazing if you've seen any of the courses that I've put out there. And there's so many other resources. ChainShot is phenomenal. Moralis has Moralis Academy, which is very good. I made a video there a while back as well. Smart Contract Programmer, DApp University, you know, the Moralis 3 YouTube, the list goes on and on and on. And additionally, one of my favorite places, if you're looking for boilerplates, is going to be the Solidity and Smart Contract starter kits. So I'll drop a link. I'll drop a link in the private chat. And then Phil, if you're there, you want to throw that in. But you can also just Google it. This is one of my favorite things ever. It has a whole list of starter kits for some of the most popular frameworks out there. So if you're into Brownie, Python, and Solidity, oh, thank you. Brownie, Python, and Solidity, Hardhat, JavaScript, and Solidity, Foundry, Solidity, and Solidity, Anchor, JavaScript, and Rust for Solana, Hardhat for TypeScript and Solidity, Python and Viper, Foundry with Huff, Truffle, JavaScript, and Solidity, everything you need to get started working with Chainlink or just have a boilerplate project, you can find in one of these starter kits. We can click on one of these pictures here, and we can see this is a minimized production-ready, boilerplate example of how to build contracts using Chainlink and how to get going. And if we have time, we can go through one of these, and that'll be really fun. So that's absolutely one of my favorite places. Be sure to jump into the Chainlink Discord as well, the starter kits, like I said, documentation, and definitely check out Stack Overflow, Stack Exchange, ETH. Those are two of my absolute favorite places to ask questions for people who are learning and getting started. So with that being said, oh, sorry, I have my frog up. I'm supposed to have my Chainlink thing up. Whoopsies. With that being said, I'll answer some questions now. Looks like a couple of them came in. Awesome, because that's what these live sessions are for asking
Perfect. Yeah, let's which one do you want to take first here?
Let's see. Let's start from the top. Okay, the Chainlink Keepers are using something like cron. Great question. So kind of. So you can think of Chainlink Keepers as a cron plus a bunch of other stuff. So for those of you who are unfamiliar, cron is this really cool Linux scheduling tool. It allows you to say, hey, every day I want to do X. Every second I want to do Y. Every month I want to do whatever. So in your contracts, and actually I can even pull up, let me pull up the keepers and I'll show you right here. We'll go back to code. So there's two basic kinds of automation. There's time-based automation, which is literally exactly like cron for your smart contracts, and you can check that out. Or you can do custom logic automation. And to me, this is the real power of the Chainlink Keepers. So if we scroll down, we can see an example here. This is for registration. And here is a Keepers compatible contract. So what we have, and actually I'm just going to open this up in a remix because it'll look a little nicer. what we can see is we have these two functions. One is check upkeep, and then one is perform upkeep. So this check upkeep function gets called maybe every 20 seconds or so. It really depends on the blockchain. Quicker chains like Polygon checks a lot more frequently. Slower chains like slower chains like Ethereum, it checks a little bit less frequently. But every maybe 20 seconds or a minute or so, it'll call this check upkeep function. And this is a function that you can implement, right? So you just create this check upkeep function, and if it returns true, it'll call perform upkeep. So this check upkeep is you saying, hey, let's check to see if it's time to do something. And they just keep calling this function over and over and over again. Hey, do I need to do anything? Do I need to do anything? Do I need to do anything? Yes or no. Once it's true, it'll call perform upkeep. In this example, this is an example where it's real minimal, where all it does to check if the upkeep is needed is it checks the current block timestamp minus some last timestamp is greater than some interval. So this is going to be an upkeep that's just triggered every X seconds, right? So this is really similar to a cron. And then all it does on this perform upkeep, once the interval is passed, once enough time has passed, all it's going to do is it's going to update the last timestamp, and then it's going to update some counter, right? So let's say if you had this interval be 60 seconds, basically what would happen is every minute, this counter would get updated by 1, right? And that's how Keepers works. And that is a phenomenal question. Thank you so much for asking. So currently companies have so many cron jobs in Kubernetes. Yes, they do. Okay. Next,
looks like we have a follow-up one here too.
Love follow-up questions. Great. What about possible security issues with outside APIs? Recently, API hacking has come into light. Any tips or best practices? And what about contract security? I love this question. Amazing question. Yes, very like this is exactly how you should be thinking. So thank you for asking. Sorry, there's a airplane going on overhead. Hold on one second.
Oh, we're not picking it up on the mic.
Oh, really? Oh, okay, great.
I think we're good. Yeah.
Nice. My mic fiddling has gone well then. So security issues with outside APIs. This is where decentralization is your best friend, right? If you're running a centralized application, you have to worry about that stuff, right? In the same sense, you could ask the question, well, what about malicious Ethereum node operators? What about malicious Polygon node operators? What about malicious Bitcoin node operators? They exist, and we don't really care.
That's what the consensus is for.
That's what consensus, exactly, right? So when you're working with these APIs, again, as an MVP, you can work with one, that's fine. When you scale up, you need to make sure you have that tailored in. So with price feeds, for example, most of the node operators are calling APIs, right? They're calling maybe out to Binance, maybe out to Coinbase, maybe out to CoinGecko, maybe out to CoinMarketCap, right? All these APIs. And if a couple of them are malicious, great. They flip those off. They don't use those anymore. And they go find APIs that are being consistent, being reliable. And everyone, and the exact same thing as Ethereum, where there will be nodes who are being malicious, there will be APIs that are malicious. But that's why the decentralization is so important, especially with this data. So you want the data to be centralized, but not only that, you want the node operators to be decentralized, right? In Ethereum, if 90% of the node operators are secretly one entity, you have an issue, right? Because once again, it's centralized. So with getting data, it's the exact same thing, right? You want to have multiple Chainlink node operators bringing data in from multiple sources. And that's how you get these guarantees about what the state of the real world is for your smart contracts. So amazing question. So for best practices for working with price feeds, and this is the beauty of price feeds, the work there is already done. The node operator is already decentralized. The data feeds are already decentralized. That's good. You're good to go. You can just use those out of the box. For custom data, that's where a little bit more work might be needed on your side to build a production-ready application. We have seen some projects bootstrap a decentralized Oracle network, which is phenomenal. It definitely takes a little bit more work, though. And what about contract security? I feel like I just answered a lot of that there. Contract security, obviously, definitely important for building your smart contracts. Amazing question. Yeah, I would love to see more questions like that. That was a great one.
All right. Well, we've got time for more questions here if you guys have any.
And if there are no more questions, we'll take a little poll here on what you want to see next, because we do have maybe 20 minutes left here. So if there's any other questions, we can go into it. If not, okay, we do have a question. Proof of reserve. What about it?
Give us a little more than just 3 words.
But yeah, if you have more questions, ask them in the chat. Otherwise, put in the chat what you want to see next. Do you want to see Remix using deploying a price feed live? Do you want to see us doing, one of the starter kits with Brownie, with Hardhat, with Foundry? Do you want to see, any of the UIs for Keepers, for Chainlink VRF, for the data feeds? What do you want to see? Because there's so many different places to go, so many different cool things to see. Do you want to see DeFi minimal? Do you want to see the repo that I have where we've broken down all these massive DeFi contracts like Aave, like Maker, into these minimized examples, and kind of like talk about how you can build your
something
own?
I'd like to see, Patrick.
Okay.
Why don't we start with that and see if we get any other questions?
All right. If Phil is the only voter, we're doing DeFi minimal. I love it. Let me just pull that up here. So, but yes, people post in the comments what you want to see. Second. All right. The Rich seconded. I'm not sure what the Rich seconded, but he seconded something. Let me just hold on.
Maybe he's seconding my proposal.
Ooh, yes. Excellent. All right, hold on. Let me just pull up my code here. I have like 1 trillion tabs open. I should close some of them. Give me 1 second. We're going to close some of my tabs here. I'm assuming he's pulling your proposal there. All right, cool. That looks good. I want to make sure I'm up on the latest branch as well. All right, we're going to do a little flipping over. Okay, so here is, and we have a quick question. Keepers is my thing I want to see. How can I use, let's say, an external API? So good question. So for Keepers and an external API, you'd follow the docs here, and then you just put in this kind of make a GET request, make a POST request, or really whatever you want. So all the docs you want is right here. Again, you can open this up in Remix, and this is everything that you need to know to make an API call through Chainlink. So go to this connect an API, and then single word response, multivariable response, whatever kind of response that you want to bring on chain. So great question. All right, DeFi minimal. So this is DeFi minimal. It is a repo dedicated to minimizing some of these massive contracts out there, some of the most popular contracts out there. So if we go into the contracts folder, we can see a whole bunch of different examples. So we have lending.sol, which is a borrowing and lending minimized contract, kind of like Aave, kind of like Compound. We have options.sol, which is a minimized options trading contract. Reward token.sol, which is going to be kind of your traditional ERC20 reward token. Staking.sol, which is based off of these synthetics original staking contract, which is one of the most influential contracts out in DeFi. And then we have swap.sol, which is a minimized contract for working with like Uniswap, SushiSwap, and many of the most popular exchanges out there. We also have a minimized Uniswap V1, which is going to be your traditional decentralized exchange. And then the newly added, and one of my favorites, is this stablecoin section where you can build stablecoins. And to me, stablecoins are particularly interesting. And I know there's kind of a lot of words here. I'm making a video that's going to explain everything here because there's a lot of information out there about stablecoins that I think is a little bit confusing. But to me, they're really, really cool. And we're seeing this huge push on stablecoins, and I'm about to nerd out. So maybe I'll talk about that later. But some of the ones that people really like to see, some of my favorite ones are going to be like this lending.sol, right? So this is going to be your minimized, and then we can even go into my VS Code here. And this is going to be your traditional kind of borrowing and lending. And what I really like about this and a lot of these contracts is most of DeFi kind of borrows about 80% of the same things from each other. right? Most of these DeFi contracts need a way to deposit collateral, right? In most of these, you're going to see something like deposit, or maybe they'll call it like stake or like add liquidity. There's all these different function calls when it's really just send money to this contract, right? And then when you have a send money to this contract, you also have some type of withdraw, pull money from this contract, right? And this one's interesting because it has like borrow, it has liquidate, if you're familiar with liquidation, repaying, et cetera, et cetera. So if you clone this repo, what you can do here is then you can run yarn a hard hat test. Well, after running yarn, run yarn hard hat test. Actually, what do I have in here? Yeah, okay, yarn hard hat test. And it'll go through all of these tests, which show kind of the minimized. Oh, it looks like I messed one up. I've been playing with these, so I might not have the most up to date. But it'll show you kind of the minimized ways to interact with these contracts, to interact with all these protocols. Yeah, looks like I messed something up. I'll fix that later. One failed out of 53. That's not bad though. Yeah, and I think it's really cool. One of my favorite contracts too. Oh, and then the other thing that's really cool about lending, scroll to the top, of course, it's using Chainlink. Because like I said, Aave, Compound, all these massive DeFi protocols. This is pretty much exactly what they're doing, right? And this is what it's 217 lines of code where boom, you now have a lending protocol, a really, really minimized lending protocol. And it's an easy way to digest what these protocols are doing. Now, one of my favorite contracts here is this staking protocol. This one I think is a little bit trickier to understand, but if you're looking to build some type of protocol that gives some reward, that enables people to stake, this is one of the most influential contracts on the planet. Like I said, it's based off the synthetic staking contract. And once again, it's 132 lines of code, really minimized for people to kind of jump in, see, okay, that's how it works, and go from there. So to me, this is like one of my favorite products to work on when I have time, because it's so fulfilling to be able to say, okay, that massive contract with thousands and thousands of lines, here's really what it's doing. Here's the minimized version of what it's doing. So that's that. Any questions on DeFi Minimal? Yeah, I highly recommend, if you're looking to build something in DeFi, take a look in here, see, okay, like maybe I want to build a DEX. Okay, cool. Look at the AMM contracts, right? Look at the Uniswap V1 contracts. Okay, I'm looking to build a stable coin. Okay, jump to the stable coins example. There's all these big words, endogenous and exogenous. We can talk about that if you're interested. But they're good examples of kind of some of the most popular stablecoins, like DAI, like USDC, like RAI, etc. Any questions on DeFi Minimal here? I'll take that as a no. That's great. Okay, cool.
Really cool stuff though. Like it's like a toolkit of everything you need to launch a DeFi site. And I mean, for anybody who's listening who doesn't know already, the Uniswap V1 AMM model is by far and beyond the most common decentralized exchange model in existence. There are advancements that people have made, but none of them have really rewritten the book on how decentralized exchange works. So starting with that, I mean, you're dealing with something that is well researched, that has been used 100 times already, and that it's at least going to do what you expect it to do. It's just really cool.
Definitely 100%. Yeah. And so Uniswap V2 and V3 are out as well, but you can really understand the basics really easily by checking out V1 for sure. So great.
Yeah,
question.
always learn V1 first. The version 2 and version 3 AMM models become significantly more complex with weighting and all other sorts of things.
But the cool thing is they're pretty much the same thing. They're just with a whole bunch of advancements, right? The underlying mental model doesn't really change, which is really
Exactly. Yeah. It's the simple concept of you have two pools of assets. If you add to one pool, you get some of the other pool, and vice versa. I mean, that's what we're talking about here. And Uniswap V1 is going to be, certainly the most famous instance of that. Very cool.
Definitely.
Any other questions? All right. Well, Patrick, thank you so much for taking time with us today for this workshop. Really exciting, great interactions. Do you have time to join us in GatherTown afterwards?
I unfortunately will not.
That's okay. And then because you say that, I'm going to bring this up. We have a few more GatherTown sessions throughout the rest of the week. All of you are invited. The link is in the chat below. I'm going to do my best to be there at every single one, along with members of my events team, members of our community engineers, and of course, all of our sponsors are welcome as well. So thank you again, Patrick. Have a wonderful day. Happy merge.
Happy merge, absolutely.
We'll look forward to seeing everybody at the next live stream and in GatherTown. Have a great day.